My dear friends, we are meeting once again on large power transformer protection. We have seen the incipient or minor faults and the remedies against that. And then we have entered into external faults or through faults. So how the overcurrent and earth fault protection are coordinated, that we have seen in that. And with that, we started the internal faults also. But in internal faults, we had taken only earth faults. Earth faults on primary winding, or so to say, restricted earth faults on primary winding are taken care of by the ground relay connected in the residual circuit of 3 cities in primary. Whereas the on star side, we have a special arrangement that we have seen, and we have calculated an example also to find out the value of the stabilizing resistance to make the relay stable against external faults. Because you see, so often the line cities and neutral cities, usually neutral cities will not match. So therefore, to stabilize, we have used the stabilizing resistance, and we have seen how to calculate that. And also we have found out the knee point voltage of the transformer to make the protection perfect. So complete engineering process of internal earth faults have been seen. Now in this tutorial class, we are going to go to differential protection. Differential protection of a power transformer is most complex and most difficult protection. No engineering colleges are teaching to the depth to which it should be taught. To be very frank, differential protection has not proved 100% perfect as on date, and therefore researchers have yet chance to take up differential protection of power transformer even today. What I mean by that is this, that if there is an internal fault, the relay does not operate. I mean, in a very rare cases, but it does not operate. And for external fault, it operates, which should not be the case. And that happens. And the solution to that problem may be rare, maybe 1%, 2%, but it has not been found out. So differential protection is a very complex protection. But to start with, rare 98%, the differential protection is most reliable, right? Because the zone of protection is only between 2 cities, and transformer 2 cities hardly 10 or 20 meter apart. So I mean, not a big pilot wires are to be used. So no big voltage drop in pilot wires also. Another thing, it is very accurate. Just after the transformer, relay will not operate, and just within the zone of protection. That means within 2 cities, primary side cities and secondary side cities is the zone of protection. It certainly operates. And very speedy. It instantaneously operates. Nowadays, one cycle operation is possible with numerical relays because it is taking samples every 1 millisecond. You see. And to take a decision for the relay, it needs only 3 samples. That is, within 3 milliseconds, it will be able to tell you that there is a fault, and it will give a signal to the breaker. Then only the remaining time is the breaker time, which also one cycle breaker are available now. So very fast protection is possible. No doubt, 3 sample technique is not that accurate. I mean, it may respond to noises and harmonics. Therefore, people use half cycle Fourier algorithm in which you will be able to sense the fault within half a cycle, that is 10 milliseconds. And full cycle Fourier algorithm, 100%, 20 milliseconds, is the most accurate protection in numerical world. So one cycle for relay and one cycle for breaker, two cycle is not a big time. So for internal faults, differential protection only has to be preferred. But when you apply differential protection, there are many problems. So we want to see each problem and then we'll try to see what are the remedies. The first thing is very common, that whatever problems we have seen, some 5 problems in generator differential protection, hold good here too. But beyond that, there are some more problems. In generator, neutral side CT and line side CT were rather having the same ratio, right? Here, the primary side CT and secondary side CT, if you have 11 kV by 132 kV transformer, primary side CT are 11 kV CT, secondary side CT are 132 kV CT. It is quite possible that some manufacturers are uh, manufacturing CTs on low voltage side only, that is 11 kV, 6.6 kV, and some manufacturers are manufacturing on 132 or 220 or 400 or 765. So manufacturers differ, and because manufacturers differ, the possibility of mismatching is more. Possibility of mismatching is more. One thing, right? And therefore, in generator, you are using high differential protection. That was all the time good. In generator, people are using low differential, that is bias differential protection, or percentage differential protection is also applied. But in transformer, you have to use that percentage differential protection or low resistance differential protection. That means you have to have restraining coils and operating coil. So now we'll see what are the purposes of this restraining coil. Restraining coil restrains the operation of the relay. It blocks the operation of the relay. And operating coil tries to operate the relay. Now, whosoever wins, the relay will go to that side. This is one thing. Another thing is full load current on primary and secondary sides are different because voltage ratio is different. Right? So if you have 132 by 66 kV transformer, on 132 kV, if you use 500 bar 1 CT, then on 66 kV you have to use 1000 bar 1. So that finally pilot currents have to be same, because our main point is pilot currents have to be same, equal. This I was talking about 132 by 66 AV. But if I have got a 15.75 to 240 or 220 kV transformer, then on 15.75 I have got the current 9050 ampere. And on secondary side I have got some 601.16 or something, or 656 ampere or something. So you see, nobody will give you a CT of 656 bar 1 or 9050 bar 1. One thing, 9050 by 1 is not at all possible. When the primary current is high, you have to go for the secondary rated current at 5 ampere. And 9050 is not standard available. And standard ratios only have to be used because CTs are to be tested, and CT manufacturer cannot test at varied primary and secondary current. And test laboratories also cannot rig up so many currents, because you see it is very, testing laboratories are very costly. So in CT, chapter of CT, we will see how many standard primary currents are available. Secondary standard currents are only two, 1 ampere and 5 ampere. So what happens that on primary side you have a ratio 10,000 by 5, and on secondary side you have 750 bar 1 or 1000 bar 1. So when you take it to secondary, the pilot currents are not equal. And when pilot currents are not equal, you will have to use ICT, interposing CT. It is a 660 volt CT. It is not for high voltage. You see, we have come to secondary. So it is a CT which can be easily manufactured. It is very cheap also. And you change the ratio to 1 is to 1.4 is or 1 is to 1.6 or whatever as per requirement, so that finally pilot currents are equal. So these are extra difficulties in the transformer differential protection. Then you see, you say 132 kV by 66 kV means 132 kV my current is 500 amperes, so 66 kV is 1000 amperes. That is actually wrong, because transformer needs some excitation current. So if the secondary current on 132 by 66 kV transformer is 1000, then on primary side it is not 500. It may be 502 or 505. Some excitation current is taken, and that excitation current is a difference, and that difference will pass through the operating coil, and it can make an operating tendency. So while setting a basic setting, you see there are two settings that I have written here, that the differential relay, percentage differential relay, two conditions are required. That is, current passing through operating coil must be higher than certain pickup setting or sensitivity threshold or basic setting, whatever you want to call, right? And another very and means A and D all capital. I'm talking of and logic. And I1 minus I2 upon I1 plus I2 by 2. I1 minus I2 is operating coil current, and I1 plus I2 by 2 is average restraining coil current. That ratio, which is known as pickup ratio, must be higher than certain prefixed bias, which is settable. Sensitivity threshold is also settable. Bias is also settable. So using proper basic setting, you can avoid the maloperation due to the normal magnetizing current. Actually, normal magnetizing current of large transformer is hardly 1 to 2%, and bias setting available in most relays is not less than 10%. So this does not pose a big problem, right? So this is one thing. So this is what I told, that I1 minus I2 should be greater than I pickup, which you may call basic setting or sensitivity threshold, and I1 minus I2 upon I1 plus I2 by 2. I1 plus I2 by 2 is base average restraining coil current, and I1 or stabilizing current, and I1 minus I2 is operating coil current. This ratio, pickup ratio, must be higher than M, which is settable. It is known as bias setting. So that bias setting you should properly do, so that relay is stable against external fault and very sensitive for internal faults. I1 minus I2 may increase beyond basic setting if external fault occurs. But at the same time, I1 minus I2, I1 and I2 also will increase. So I1 minus I2 upon I1 plus I2 by 2 will not be greater than M. Thus, the maloperation in through faults will be avoided. Yes, right. So relay setting you have to properly calculate, and you should know. And how to calculate the relay setting, no engineering college in Gujarat state is teaching, right? So these things which I am trying to teach to you are beyond the scope of many engineering colleges in Gujarat state and in India. I don't know about foreign countries. That you are the best judges. And therefore, I am keeping on telling that these videos are very important. One who listens to this video, he should share this to 10, 50, 100 people. It should go to millions of people. And my viewers should touch 4,000 within a month or so, which is yet 800. So I don't know. Protection, which is a very important subject in any generating plant, in any substation, in any transmission line. You see, that is that is not getting that importance. So I would request again and again that share to 10, 50, 100. This video should go to billions of people and not 4,000 viewers. It should be million viewers in the YouTube, because YouTube is free of cost. I am giving such an important knowledge, and I am not boasting, but I am number one protection engineer academically and industrially in Gujarat state, at least, if I don't talk of India. So such a knowledge you will never get. I am getting such messages also that we have not learnt any such thing in universities, because now they are in industries, they are understanding better, because now they have to do work. So they are not being able to work because they are not knowing many things. Now because of this they are being able to do better work. They are praised by their bosses. Everything will happen, but you have to listen to the video fully. I'm seeing that I'm getting many likes, but I doubt whether all those people who are liking are reading. You should read the full video. Leave away my students because they have studied, so they may mean that we have studied all these things. We need not hear the video of Oza sir. But then also I would tell that when they were studying, they were not mature. Now they have 20 years, 30 years, for 32 years of engineering experience. Now if they learn here, then they will be able to understand many new more things. So they should also hear. And those who have not heard at all, they must hear. So I earnestly request, hmm, that everybody should listen to the whole video so that my viewers touch a big figure. Right? But Adapt Me, the organization, is known in the whole world that I want to see. Organization is started by my sons. They are doing business. I want to see to it that the name of Adapt Me, if somebody takes in UK or Russia or Argentina or Philippines, everybody will tell that yes, we've heard the name of Adapt Me. They are doing very good work in the educational field. Educational field is their uh, business. No doubt on YouTube they are not earning. They will earn in different way that I don't know. I do not want to know also. But whatever knowledge I have, I am trying to give to you through this YouTube. Yes, going ahead. Another very important problem, that all transformers in power system are delta Y. Once I told you the reason, that the reason for delta Y transformer is, nowadays you see our many loads are non-linear. Say all power electronics load. You see, in earlier days, for varying speeds, people were using DC machines. Now DC machines are gone. People were telling that induction motor is a constant speed machine. That is gone. You see, that criteria, that fact has gone. And yet the teachers are teaching the same because they do not know. Induction motor speed you can change from minus 1440 to plus 1440 in a very small steps, using power electrics, using thyristor drives. But those thyristor drives are very non-linear. That means there are heavy harmonics in that. Fundamental, third, fifth, seventh. Second is not there usually, because the most of the machines are symmetrical if you cut them in two parts, two halves. Therefore, second, fourth, sixth, eighth harmonics are not there. They will be there if the core saturates. That is a different thing. Second harmonic will be there if the core of the induction motor, core of the transformer, core of the generator rather saturates. That is a different thing. Otherwise, first, third, fifth, seventh, they are very, up to seventh, they are quite large. Beyond seventh, probably you may forget, because it would be in terms of 0.5% or 0.1% or 0.12%. But third is so often 18% or 19%, which you cannot forget. And third harmonic, if it passes through transformer, the eddy current losses are proportional to square. So eddy current losses will be 9 times. However, the magnitude is less, but because of frequency, it is 9 times. It can damage the transformer. It can damage the insulation of the transformer. And if you allow further, then if it goes to generator, generator will be certainly damaged due to harmonics. Generator can withstand only 5% of negative phase sequence current. So if you have a delta Y transformer, on Y side winding, third harmonic will be there, right? But in primary side, because you connected it delta, in delta winding, harmonics will be there. IR is equal to IR1 plus IR2 plus IR0. IY1 plus IY2 plus IY0. IB1 plus IB2 plus IB0. But when you come to line, it is IR minus IB. So I0 is in phase, I0 is gone. First and second harmonic only remain. Therefore, to suppress the third harmonic, we are using delta Y transformer. But when we use delta Y transformer, we are thrown into another problem, that there is a 30-degree phase shift dy11, dy1. In one case plus 30 degree, another case minus 30 degree. That means primary and secondary currents are not in phase. Primary and secondary currents, by using proper CT ratios, high voltage CT ratios and proper ICT, you have brought pilot currents equal magnitude wise, but phase wise they are yet 30 degree apart, and I1 minus I2 exists, and that can lead to an operating tendency. Here, you cannot do anything in the relay, right? You cannot do anything in the relay. What you can do is this. You see, I have shown here transformer DY11, IRL, IYL, IBL are free of not only third but triple harmonics. Third, sixth, ninth are gone. Seventh usually is very small, but fifth and seventh also can be removed by short pitching the generator winding. Uh, then question remains of 11, 13, 17, which are in the decimals, 0.05 or 0.07. You may not have to worry for them. So this is how the transformer is found. And then if you see the IRL, so what happens? IR plus IB is IB plus IRL is equal to IR. IB plus IRL. So IRL is equal to IR minus IB. IRL is equal to IY minus IR, and IBL is equal to IB minus IY. And when you plot it, the characteristic IR is equal to IR minus IB. IRL, IBL, IBL you are seeing. So IRL is at 30 degree to vertical. But your secondary winding is IR, IY. We have used small r so that you can understand that it is secondary winding. Now, if you compare IRL, R phase, and IR in secondary, and if you keep IRL on 12 o'clock position, IRL small, IR, small IR, secondary winding is 30 degree leading. It is plus 30 degree. And if you refer to your clock, it is 11 o'clock. So this is also known as DY11 connection. DY11, I was studying, I never understood how it is DY11. I myself then tried a lot and found out that this is why it is called DY11. Similarly, if you connect delta in a different way, that is R1 with Y2, R1 is the starting of R phase, R1 with Y2, Y1 with B2, and B1 with R2, it will be DY1. And on secondary side, you see, I have used R2, Y2, B2 as star point, R1, Y1, B1, I am heading road, because I capital R is flowing from R1 to R2, I small r is flowing to R2 to R1, because in any transformer 180 degree phase shift will be there. So this is how the DY11 connection happens. Now, how to avoid this 30 degree phase shift? For avoiding this 30-degree phase shift, right? Uh, for avoiding the 30-degree phase shift, what you have to do is this. You have to connect. I'm sorry, some slide has missed. It has missed this. This is conversion of primary and secondary vectors. This is true. This we have seen. Then vector diagrams, primary transformer, secondary transformer. This we have seen, right? And then we are seeing primary and secondary of CT. In this one figure is missing. I'm sorry, but I can explain to you that figure. I cannot now redraw. But what do we do to avoid this problem? CT on line side, that is CTs will be connected on IRL, IYL, IBL, not within the transformer. So those CTs are star connected. Delta side CTs are star connected and Y side CTs are delta connected. If you do so, then you will see that the star connected CT will, this is transformer, right? Transformer IRL is there. So IRL will be 180-degree phase shifted because in CT it will be phase shifted. So IRL phase shifted, IBL phase. These are CT connections on primary. IR, IY, IB, not that lines are shown, right? IR, that is 180-degree phase shift. It was upwards. It came downwards. But now we are connecting in delta. So what is coming out is IR minus IB. So IRL, I small and RL, I small, YBL and YL and BL. You can see that IRL and IRL now are in phase. So we connect delta side CTs in star and star side CTs in delta. This is the problem of phase shift. There are 4 or 5 more problems, and some of the problems are, as I told you, unsolved. Not fully solved, I should say. I should not say unsolved, but not fully solved. In 2 or 3% of the cases, maloperations do occur. But that would be too long because differential protection of transformer itself is very complex. And therefore, I end my speech here. Stay tuned with Head Up Me. Right? And share the knowledge as I told to you. I want to see 4,000 viewers because that is the first milestone in YouTube. 4,000 viewers I want to see within a month or at the most 2 months. And that is not dependent on me. That is dependent on my learned viewers. They have to view. They have to view for half an hour. Right? And they will learn knowledge. Some knowledge, 5% knowledge, 10% knowledge, 20% knowledge, depending upon the person. If the person is very learned, he would learn only 5% out of this. Or he may not learn at all. Then he will at least be able to say that yes, this material is good because I know that this material is not learned by many people. So at least he will be able to appreciate, right? So whether you have learned all these things, whether you know 5%, 10%, 20%, and if you do not know anything, then you will certainly earn a lot. Not in terms of money, but in terms of knowledge. And knowledge turns into money because you will be appreciated in your factory. You will get fast promotions and you will get more money by that. So knowledge is also a money. See, I am getting many offers. I'm going to PDPO and Nirma, which I'm going to discontinue from next semester because of my personal reasons. But meanwhile, Adani is rather, Adani is 1,000 GETs are required in Adani. Adani is starting a new petrochemical plant, and they have already appointed one training head. 1,000 GETs, graduate engineer trainees, will first be given a training for 6 months or a year. And as a trainer, I will be one of, I mean, there will be more than one trainer, 10 trainers may be there, because everybody does not know all subject. I know protection, power plant, and general engineering, project engineering. So in these areas, I can talk. And I have already got an offer for that. I have got an offer from Bhubaneswar. I don't know how people knew me from Bhubaneswar, but I got offer from Bhubaneswar. And I doubt I will get 5-10 more offers. So you see, knowledge is money. They will pay me, obviously. So I will get money. So stay tuned with Head Up Me, share Head Up Me, like Head Up Me, subscribe Head Up Me. Let the name of Head Up Me rise in the sky as the stars are. With that, my friends, I thank you so much and good day.